going to do is 4.7 L'Hopital rule, and the question number is 51. So the question basically says as x goes to 0 from the positive side, what does cotan x minus 1 divided by x equal to? So if you want to use the L'Hopital rule, we have to see if it's in an indeterminate form. So let's first check that out. So we sub in 0 x as 0 0 from the positive side, and when we do that, sine x goes to goes to a really small 0 value, and it goes to infinity, while 1 divided by x also goes to infinity. So this is not an indeterminate form. The only indeterminate form that we learn of is 0 over 0 and infinity over infinity. So what we have to do is we have to rearrange the formula to get a 0 over 0 indeterminate form. So what we have to do is, what I did was that I made the denominator the same. This denominator is the x, and well, this denominator is sine x. So I just cross multiplied them, and I got negative cosine x minus sine x divided by x sine x. The blue is the numerator, the red is the denominator. So let's just sub in 0 as x again to see if this is in the indeterminate form, and you can use the L'Hopital rule. So when we did that, x goes to 0, cosine x is equal to 1, and sine x goes to 0. While x goes to 0 again, and sine x goes to 0. So what we get is 0 over 0, which is an indeterminate form, and we can use L'Hopital rule. So when we use the L'Hopital rule, it's really easy. The numerator, we just use the product rule here, and then we find the derivative of sine x, then we use the product rule on x sine x. So this is all the area over here where I showed my the proper notation, and what we get is 1 times cosine x plus x, negative sine x minus cosine x divided by 1 times sine x plus x cosine x. So when we expand it all out, we times it, we get cosine x, negative x sine x, negative cosine x divided by sine x plus cosine x. So what we do is remove the cosine x and the negative cosine x and the positive cosine x, and what we get is negative x sine x divided by sine x plus cosine x. So now we sub it in again to see if what our answer is, and if it's still in the indeterminate form, we have to use L'Hopital rule again. So when you sub it in, we get negative 0, which is a 0 as well, and x sine x is equal to 0 divided by 0 plus x turns to 0 again, and cosine x is 1. So what equals to 0 over 0 again. So we're going to use L'Hopital rule again because it's still in the indeterminate form. When we use it again, for this we use the product rule. For this is just the general derivative, and then for this we use the product rule. All of my information is right here on my proper notation. What we get is basically negative sine x plus negative x cosine x divided by cosine x plus cosine x plus x negative x sine x. So what we have is 2 cosines, and then we make it equal to 2 cosine x, and then this is our basic answer. Then we have to sub it in again. Sub in x is equal to 0 from the positive side. When we sub that in, we get negative 0, which is basically 0, minus x turns to 0, and cosine x is 1. And then this is the key, important part here is 2 cosine x is 2 times 1, which we finally got one number here, and then x is also 0 again, and sine x turns to 0. So what we get is 0 divided by 2, which is equal to 0. So we got our limit here, which the limit is the limit as x goes to 0 from the positive side for cotan x minus 1 divided by x is 0. Just for evidence, I'm going to use an online graphing utility which is called Desmo. And when you look over here, this is our function here, cotan x minus 1 divided by x. If you go right here, you can see 0 from the plus side, we go to 0 again. So my answer is right. Thank you very much.